In this video, I am going to discuss about structures of oxides of sulfur. Actually, in first year, first sem of chemistry syllabus, P block elements is the one of the unit. In this unit, the subtopic is 16th group elements. In this, we have the structures of oxides and oxoacids of sulfur. So, let's start the oxides of sulfur. Before going to the topic, we should know the sulfur is which group element and what is the atomic number of sulfur and what is the electronic configuration of sulfur, etc. like this. So this is a periodic table. These are the S block elements. These are the S block elements and these are the P block elements and these are the D block elements and these are belongs to the F block elements. We know that the group number 13, 14, 15, 16, 17 and 18 are the P block elements. In P block elements, the green colored, so first in P block elements, the blue colored mentioned, so this, the blue colored mentioned are metals and the green colored mentioned elements are the metalloids. The purple color mentioned elements are the nonmetals and the pink color mentioned elements are the radioactive elements. So this is a brief note on P block elements. Now we will concentrate on the 16th group elements: oxygen, sulfur, selenium, tellurium, polonium, livermorium. So these are the 16th group elements: oxygen, sulfur, selenium, tellurium, polonium. In this, oxygen atomic number is 8, sulfur atomic number is 16, selenium atomic number is 34, tellurium atomic number is 52, polonium atomic number is 84. The electronic configuration of these elements are electronic configuration. Oxygen is helium, helium 2s2 2p4, and sulfur is neon 3s2 3p4. Selenium is argon 3d10 4s2 4p4. Tellurium is krypton 4d10, 5s2, 5p4, and the polonium is xenon, 5d10, 4f14, 6s2, 6p4. This helium atomic number is 2. Neon atomic number is 10. Organic atomic number is 18. Krypton atomic number is 36. Xenon atomic number is 54. Sulfur is a bright yellow crystalline solid at room temperature, and sulfur is a abundant, multivalent, and non-metallic. Sulfur is a chemical element with the symbol S, and atomic number is 16. The outermost electronic configuration is 3s2, 3p4. This is the outermost electronic configuration. The actual electronic configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. It is the electronic configuration of 18th group element, that is neon. Neon atomic number is 10. So it can be written as neon 3s2, 3p4. Sulfur oxides are a group of molecules of sulfur and oxygen atoms, such as sulfur oxides are sulfur monoxide, SO2, SO3, S2O2, S7O6, like this. Among these, the important sulfur oxides are sulfur dioxide and sulfur trioxide. Here in this model, the yellow atom is sulfur, and the red atoms are the oxygen. Sulfur dioxide molecular structure. It is a structural representation of a sulfur dioxide molecule. In this, between sulfur and oxygen atoms, two bonds are there. See here, two bonds are there, and here also two bonds are there. Here also two bonds are there. In this, one is sigma bond, another one is pi bond, and here also one is sigma bond, another one is pi bond. The sulfur molecule containing two sigma bonds and two pi bonds, and one pair of electrons, See, this is. So sulfur atom contains 6 valence electrons. 6 valence electrons, out of which it shares two electrons with two oxygen atoms to form two sigma bonds and to form two pi bonds. So these two pi bonds. Here we observe one lone pair of electrons. So this is one lone pair of electrons. Let us see how the bonds are formed. The electronic configuration of sulfur is 3s2 3p4. So 3s2 3p4, 3s orbital contains 2 electrons and 3p orbital contains 4 electrons. 1, 2, 3 and then 4. So this is the electronic configuration, that means ground state electronic configuration. Ground state electronic configuration of sulfur. Here I will explain the hybridization of sulfur dioxide in detail, molecular geometry and bond angles. And then the outermost electronic configuration of sulfur is 3s2 3p4. So this is the outermost electronic configuration of sulfur is 3s2 3p4. In this, the 3s orbital contains 2 electrons and 3p orbital contains 4 electrons. 4 electrons. In SO2 molecule, so actually SO2 molecule, this is a structural SO2 molecule. Sulfur needs 4 electrons. Sulfur needs 4 unpaired electrons for the formation of 4 bonds. See, for the formation of 4 bonds, here is a 2 bonds and here also 2 bonds, total 4 bonds. This leads to the development of the excited state in sulfur where one 3p orbital electron, see here, one 3p orbital electron jumps to the 3d orbital. So here I am writing electronic configuration of sulfur in excited state. So this is electronic configuration of sulfur in excited state is 3s2 3p3 3d1. So 3s2 and 3p3, 1 2 3 and 3d1. In this, see here, in this 3s orbital contains 2 electrons, 3p orbital contains 3 single electrons and 3d orbital contains 1 single electron. For dioxide, the hybridization takes place sp2 type. sp2 type. During hybridization, the 3s orbital and see this is 3s orbital and 2 3p orbital get hybridized. In total, there is a formation of 3 sp2 hybrid orbitals. In this, 2 hybrid orbitals contain unpaired electrons. See here, 3 sp2 hybrid orbitals. So these 3 sp2 hybrid orbitals. In this, one hybrid orbital contains 2 electrons and two hybrid orbital contains one single electrons, and in this, so one this p orbital contains single electron and this d orbital contains single electrons. So see here, in this, two hybrid orbital contains unpaired electrons and one hybrid orbital will have the lone pair. This is lone pair. These unpaired electrons then form a sigma bonds with the oxygen atoms, these single electrons. So sigma bond, this electron is participated in the sigma bond and this also sigma bond. This electron is participated in the formation of pi bond and this electron is participated in the formation of pi bond. Now let's see the electronic configuration of oxygen is 1s2, 2s2, 2p4. In this, the outermost electronic configuration of oxygen is 2s2 and 2p4. The 2p orbital contains 2 electrons. So here 1s2, 2s2, 2p4. 1, 2, 3, and then 4. The outermost electronic configuration is 2s2, 2p4. 1, 2, 2p orbital, 4, 1, 2, 3, and then 4. The 2p orbital contains two unpaired electrons. In this, one 2p orbital electron is participated in the formation of sigma bond and another one is involved in the formation of pi bond. Outermost electronic configuration of oxygen is 2s2, 2s2, 2p4. 1, 2, 1, 2, 3, and then 4. Electronic configuration of sulfur in sp2 hybridization state is one hybrid orbital contains one pair of electrons and two hybrid orbital contains two unpaired electrons, right? P orbital contain one electron and D orbital contain one electron. So here also same oxygen electronic configuration, outermost 2s2, 2p4. Here also same. So here I am going to draw sulfur dioxide molecular structure. The sulfur atom, so the two hybrid orbitals contain two unpaired electrons shares with two oxygen atoms to form two sigma bonds. So one is sigma bond and another one is sigma bond. So two sigma bonds. It also shares two electrons with two oxygen atoms to form two pi bonds. So one is p pi type. This is a pi bond. Another one is d pi p pi type, and this is a pi bond. Because pi bond is formed by the, see here, this is a detailed explanation for the bond formation. So this is a sigma bond. Sigma bond is formed between sp2 hybrid orbital containing single electron and 2p orbital containing single electron of oxygen atom. This is a sigma bond. And here also sigma bond. This is also sigma bond. And pi bond is formed between, see here, in sulfur dioxide, two pi bonds are there. One is p pi p pi type. One is p pi p pi type. And another one is d pi p pi type. See, this is a pi bond. And this is a pi bond. See here, the pi bond is formed by the d orbital electrons and p orbital electrons of oxygen atom. So it's called d pi p pi bond. Sulfur dioxide, sulfur is in sp2 hybridization, and it's with two sigma bonds and one lone pair of electrons, and its geometry is bent or V shape. Some characteristic of sulfur dioxide are it is a colorless gas, it's highly soluble in water, it is an acidic oxide. Above 5 ppm is harmful to human beings and plant kingdom.
Sulfur trioxide. Oxide molecule, the yellow atom is sulfur and the red atoms are the yellow atom are the sulfur and the red atoms are the oxygens. This is a structural representation of sulfur trioxide. This is a sigma bond. This is also a sigma bond, and this is also a sigma bond. Total 3 sigma bonds and 3 pi bonds. Here is the one pi bond, here is the pi bond, and here is the pi bond. So 3 pi bonds. So that sulfur needs 6 unpaired electrons for the formation of 6 bonds. So total number of bonds of sulfur is 6 bonds. So that sulfur needs 6 unpaired electrons. Here I will explain the hybridization of sulfur trioxide and molecular geometry. The outermost electronic configuration of sulfur is 3s2 3p4. So 3s2 3p4, 1 2 3 and then 4. In the first excited state of sulfur, the 3p orbital electron jumps to the 3d orbital. So this is the electronic configuration of first excited state of sulfur. In this first excitation, 3p orbital electron jumps to the 3d orbital, so that the electronic configuration is 3s2 3p3 and 3d1. 3s2 3p3, 1 2 3 and 3d1. In the second excited state of sulfur, the 3s orbital electron jumps to the 3d orbital. So see here, this is the electronic configuration of sulfur in second excited state, 3s1 3p3 3d2. So in this 3s electron jumps to the 3d orbital. So 3s1, 3p3 and then 3d2. So in this, sulfur contains 6 unpaired electrons in the second excited state. So see here 1, 2, 3, 4, 5, 6. In sulfur trioxide, the hybridization that takes place is sp2 type. sp2 type. During hybridization, one 3s orbital and two 3p orbital gets hybridized. So see here one 3s orbital and two 3p orbital gets hybridized, so that there is a formation of 3, so see here 3 sp2 hybrid orbitals, 3 sp2 hybrid orbitals. In this, 3 hybrid orbitals contains unpaired electrons. See, this is a 1, 2 and then 3. 3 unpaired electrons. The unpaired electrons form 3 sigma bonds with the 3 oxygen atoms. So these all are involved in the formation of 3 sigma bonds. And see here one 3p orbital containing unpaired electron and d orbital containing 2 unpaired electrons. These 3 single electrons are participated in the formation of 3 pi bonds. Okay. So this is a oxygen atomic number is 8. We know that. And the electronic configuration of oxygen is 1s2, 2s2 and then the 2p4. 1s2, 2s2, 2p4. The outermost electronic configuration of oxygen is 2s2, 2p4. We know that 2s2, 2p4. The 2p orbital containing one electron is participated in the formation of sigma bond. This is sigma bond. And another 2p orbital unpaired electron is participated in the formation of pi bond. Okay. Outermost electronic configuration is 2s2, 2p4. So 1, 2, 2p4, 1, 2, 3 and then 4. Here is another oxygen. See, this is another oxygen. This is oxygen atom and here is the oxygen atom. So here I am going to fill up the electrons 1, 2, 3 and then 4, and here is another oxygen atom 2s2, 2p4. And this is the sulfur central element. Sulfur contains 6 unpaired electrons. 1, 2, 3, 4, 5 and then 6. So here I am going to draw sulfur trioxide molecule. So one central element sulfur and 3 oxygen atoms. So here I am writing. So this is the first oxygen atom. For understanding purpose, I mentioned like this. Okay. In this, the sulfur atom sp2 hybrid orbitals containing 3 unpaired electrons shares with the 3 oxygen atoms to form 3 sigma bonds. So see here, this is a 1 sigma bond and here is the second sigma bond, and here is the third sigma bonds. So 3 sigma bonds. So I mentioned here sigma bond, second sigma bond, and third sigma bond. It also shares remaining 3 electrons with 3 oxygen atoms to form 3 pi bonds. One is p pi type, and another one is another 2 pi bonds are the d pi type bonds. So see here, this is a pi bond, and it is a p pi type pi bond. And see here, this is a another pi bond, and it is a d pi type. And see here, this is a another pi bond, and it's also a d pi type pi bond. So sulfur containing 3 sigma bonds and 3 pi bonds, 3 sigma bonds and 3 pi bonds. In 3 pi bonds, one is p pi type, another 2 pi bonds are the d pi type. This is a important point. In sulfur trioxide, sulfur is in sp2 hybridization with 3 sigma bonds, and its geometry is trigonal planar geometry. Some characteristics of sulfur trioxide: it's a colorless liquid. It can also exist as ice or fiber like crystals or a gas. It is more acidic than sulfur dioxide. In contact process, it is used in the manufacture of sulfuric acid, H2SO4, and it is used as a sulfonating agent for organic compounds. See here, it's a sulfur dioxide molecule, and it's a sulfur trioxide molecule, right? In both sulfur oxides, sulfur is in sp2 hybridization, and here also sp2 hybridization. In sulfur dioxide, here is a 2 sigma bonds. In sulfur trioxide, here is a 3 sigma bonds, right? And sulfur dioxide, its geometry is bent or V shape, and its geometry is trigonal planar geometry, and its bond angle is 119 degrees. So its bond angle is 119 degrees, and its bond angle is 120 degrees. So its bond angle is 120 degrees. And in SO2, the bond length is 1.431 angstrom units. So this is bond length is 1.431 angstrom units, and its bond length is 1.42 angstrom units. Its bond length is 1.42 angstrom units. In SO2, 2 pi bonds are there. One is in this one pi bond is p pi type, another pi bond is d pi type, and in SO2, one pi bond is p pi type, and remaining 2 pi bonds are the d pi type, So these are the major structural differences between SO2 and SO3. Thank you.